Hello friends, welcome to the Things We Want. Today we learn about boilers. Let's start. First we look up on how the boilers are classified. Boilers are classified are as follows, according to their tube content. In this boilers are classified on tube content, what they carry in their tubes. These are of two types. First one is water tube and second one is fire tube. As their name indicates, water tube carries water in it and fire tube boilers carry fire in the tubes. Next category is according to their circulation. First is natural circulation and second is forced circulation. Natural circulation means water circulate from hot to cold region due to temperature difference, and in forced circulation water flows due to convection. Next classification is according to their position of shell. Shell may be horizontal, vertical, or inclined at any angle. Next is according to their number of tubes. Boilers may be classified as single or multi-tube. I hope you understand by their names. Next is according to their physical positions. Boilers may be classified as stationary boiler or movable boiler. As their name indicates, stationary boilers remains at same place, while movable or mobile boilers can be transported from one place to another. Next is according to position of furnace. It may be internal fired or external fired. Internal fired boilers have furnace inside the boiler shell, and external fired boilers have furnace outside the shell. Last category is according to source of heat. It may be solid, liquid, or gas.
Now we study about simple vertical boiler. It is the one of the simplest boiler. It can't generate pressure up to 7 to 8 bar. It is easy to control because of small size and used for small production. Coal is introduced to grate through fire hole. Flue gases travel the entire boiler through firebox. Cross tubes are situated across the firebox. Water flows through these tubes and get heat and get evaporate. Steam generated is collected in steam space. Hot flue gases are allowed to leave the boiler at appropriate height through chimney. In this boiler there is a lower chance of bursting. Let's study about Lancashire boiler. It is cylinder of 9 meter long and shell diameter is 2.7 meter. It can't generate pressure up to 17.5 bar. Its evaporative capacity is 8,000 kilograms water per hour. Coal is burnt in furnace and flue gases are allowed to flow through the furnace tubes. Flue gases travel from front end to rear end of the boiler and then from rear end to front end through bottom flue, then again towards the rear end through side flue and exhausted through chimney. Flue gases travel the entire length of the boiler 3 times. Safety valves. Steam stop valve. Blow-off cock is used for proper production control. Next boiler is Nestler boiler. Unlike other boilers, this boiler uses a dark-colored oil with high viscosity as a fuel. It is burnt with high-pressure air. Flue gases flow through and enter the smoke box again, and enter the upper set of flue tubes, and flows the entire length of the boiler, and exhausted to atmosphere through chimney. Water is surrounded by these tubes, and get converted into steam, and collected into steam spacing, and taken out through stop valve. Some boiler mountings are mounted on the boiler pressure gauge, safety valve, stop valve, manhole, fusible plug, etc. Next boiler is Babcock and Wilcox boiler. It is the water tube boiler. All the boilers we have studied earlier are fire tube. It is used for high production works. Coal is introduced on the grate through fire holes. It consists of several water tubes inclined at 4 to 15 degrees. Water enter the tubes through downtake header, which is connected with the shell through the longer tube. Steam generated at uptake header which is connected with the shell through small tube. Steam is separated in the shell and enter the superheater tubes. Steam travels the superheater tubes and gets superheated and then taken out through stop valve. Steam rises from the grate, then falls down, and then again rise up due to presence of baffles. There is a damper on right bottom corner of the boiler which regulates the air. Like all boilers, this boiler is mounted by same boiler mountings. It can't generate pressure up to 17.5 bar, but in exceptional cases it can't generate pressure up to 42 bar. Its evaporative capacity is 20,000 to 40,000 kilograms water per hour. Let's study next boiler, locomotive boiler. It is barrel-shaped boiler of length 5.21 meter and diameter 2.1 meter. It can't generate pressure up to 25 bar, but in working conditions it can't generate pressure up to 14.5 bar. Its evaporative capacity is 10,000 kilograms water per hour. In working condition 9350 kilograms water per hour at 14.5 bar. It is generally used in steam engine of trains. Coal is burnt on the grate. Hot products of combustion rises up and get reflected by fire brick arch, and flow in flue tubes to the entire length of the boiler, and then exhausted through the chimney. Water is surrounded by these tubes. Water gets converted into steam and collected in steam space. High-pressure steam is sent to the superheater for superheating, and then superheated steam is sent to the engine to do some work. Exhausted steam which leaves the engine is exhausted through the chimney. Safety valve is mounted at the top, and whistle is also located if used in steam engine. Thank you for watching. If you like the video, then don't forget to like, comment and share. Please subscribe our channel. Thank you. J. Hind.